Hello and welcome to the new episode of the Network and Cisco Packet Tracer tutorials for beginner. CRH is here, and in today's tutorial we are going to configure the side-to-side VPN in Cisco Packet Tracer. As usual, let's start by reviewing the tutorial topology. On side A, we have a network of 192.168.10.0/24, one server with IP address of .10 connected to the R2 site A as a gateway with IP address of 250. And on site B, we have a network of 192.168.100.0/24, one laptop with IP of 10 connected to the R3 site B, which acts as a gateway for site B, and the IP address is 250. We are going to create a VPN tunnel between site A and site B routers, which are connected through the R1 internet. And as you can see, these are the IP address between R1 to R2, which is site A, and R1 to R3, which is site B. So the good things about the site-to-site IPSec VPN is actually we are independent from the service provider access methods. When we don't need the static service provisioning, which we have other techniques of VPN like MPLS. Before we start the configuration, IPSec has its main features, and it provides the data origin authentication for us. In other words, we know that the traffic is coming from which source. This is help us to avoid any man-in-the-middle attack. In addition, IPSec provides the data integrity, so we are no need to worry about this packet change in a transit. As you know, this usually the VPN IPSec is we apply on a public networks like the internet, and there are chance of the packet change in between, or maybe someone read the packets in transit path, which is the data confidentiality provided by IPSec is very important. In this tutorial, we are going to use the crypto map based IPSec overview, and this is a kind of legacy method of iOS IPSec configuration, but it still is a very common method of configuration, and it's a good idea you become familiar with this method. High level of configuration are defined the Phase One ISAKMP policy, which is the initial tunnel between site A and site B. Then we define the Phase Two IPSec policy, which apply the all the security features over the original data between the two sites. Then apply the crypto map on the interfaces, which is between our site A and site B. And when we start the ping from one side to other side, technically we generate interesting traffic. Interesting traffic is a traffic that initiate our IPSec VPN tunnel and is defined by the access list. And usually we say that, okay, if 192.168.10.0 network want to reach to 192.168.100.0, site A applied the policy, put in the tunnel, and send the traffic in that way. That's interesting traffic, which is very important. So let's begin with site A. Let me open up the site A and a site B router side by side. It would be a good idea. And here we go. Yep. Go to the command line and let's get started with site A. Show IP interface brief. So only the initial configuration and interface are configured. If you are watching this tutorial, you are master of this. At this moment, I'm not worried about that. And let's ping the ISP routers 12.0.1 so we can reach to the ISP. And let's ping the other side. We couldn't reach to the other side because I didn't configure the static default route yet. So we don't have any routing default route on these routers. We're going to configure now. So show IP interface brief on the router B, and we have our WAN link 13.0.1. We can ping the ISP router for sure, and we couldn't ping the site A router because here also we don't have the static default route. So on site A router, we go to the global config mode and configure static default route, but IP route 00.0 and subnet of 0, and the destination would be ISP router. And on the other side, do the same thing, IP route 000.000 to ISP router. And now we have a ping between site A and site B. And here we go, we have a full ping 12.00.2. Very good. So we go into configuration, and as mentioned in a overview, we're starting with ISAKMP Phase One configuration. So we're going to create the crypto ISAKMP policy, and as you can see, using question mark, we can assign the priority. We can start as usual by 1, but it's recommended we go choosing some number higher than 1. So later, if you want to configure, we can choose the lower number. So let's start with 10, and now we have to define the encryption method for the phase 1, which is original initial tunnel between two router, and use the question mark. We have a different option, DAS, triple DAS, and AES. Let's go with triple DAS in this case, and now we need to define the hashing method. So hash question mark, we have SHA-1 and MD5. So we choose MD5, and now it's time to choose the authentication method. In Cisco Packet Tracer, you only have the pre-shared key. So in the real router, we have a different method using the certification or pre-shared. So pre-shared is a common. In the real world, also, no need to worry. We choose a pre-shared, and here is a Diffie-Hellman group. We can option with 1, 2, 5, and higher is more secure, and of course, the more consuming your router resources. We go with the group 2, and there is option also with choosing the lifetime. So we're going to configure the lifetime for router. So as you can see here, let's review together. And here we go. So create our crypto ISAKMP policy 10. We choose our encryption as triple DAS. We choosing our hashing method as MD5. Use the authentication pre-share. These are most important. Then after that, we choose the Diffie-Hellman group and the lifetime. We have to do the same configuration as a mirroring on a site B also. So always remember, it's a good idea if you want to start to configure any site-to-site IPSec VPN, you have this configuration and put the mirror site. So as you can see, we have a crypto, ISAKMP Phase One, we have an encryption method, hashing method, authentication, Diffie-Hellman group, and the lifetime. And as you can see on both sides, it's the same. So let's go back to our configuration and start with the site B, doing the crypto ISAKMP policy 10. Here we go faster. Encryption will be triple DAS, and hashing will be MD5. Then we go with authentication as pre-shared, and authentication use a tab, pre-shared, much more easier using the same Diffie-Hellman group 2. And finally, we have a lifetime of 86400. Here we go. So you can use a question mark as usual to see what is the best. The next step is we defining our pre-shared key, because here we define the pre-shared key as our authentication method. So we need to define that what is our pre-shared key. So the command for that is, let's exit on this, and crypto ISAKMP key, and we can put like our super powerful password Cisco 123, and what is the address of our peer. So we are using this key with which router, which we're going to use the router on a site B 13.00.3. So we do the same mirroring config here, and using crypto is use question mark here. We have, as you can see, we have a different option. So we're going to create ISAKMP key, and the key is Cisco 123, and the peer address is 12.00.2. And let's take a look at the config. So crypto ISAKMP key value here, and what is our peer address? We're using this key with this IP address. After this, it's time to create some interesting traffic, and as mentioned, we're using the ACL to create the interesting traffic, and the best way is using the IP access list, extend that, and we name it as a VPN traffic here. Very good. And we want to permit IP from 192.168.10 network to 192.168.100 network. So we go with entire /24. So if you forget about the access list, you can refer to the access list video, and we do the mirroring on a site B also. Let's check here. So we create define, and it's time for IP access list from 192.168.10 to 192.168.100/24. We do the other version. So we're using the 192.168.100 to 192.168.10, which is technically from this side of the network to this side of the network. So let's go back to site B and create our IP access list, extend that, and we call it also VPN traffic. Feel free, whatever you like to name it. It's a good idea to be a meaningful name. IP from 192.168.100 network /24 using wildcard mask of 10.0.0.0.255 to 192.168.10.0.0.255, and we have our access list here. As you can see, IP access list, extended VPN, and it allows any IP from 192.168.100/24 to 192.168.10/24. And we have a mirror on site A, which is from 10 network to 100 network. Very good. So we're good to go by configuring our IPSec transform set. Let's exit from the ACL configuration, and the command for that is crypto IPSec transform set, and by using question mark we can put any name we want, so we just name it as a T set. So it stands for transform set. You can use any name, use question mark, and these are the options we have. So let's go with anything you like, ESP like triple dash, and then by using the question mark we can have what kind of authentication we're going to use, and for this one we can choose ESP, for example MD5 HMAC. So here we go, we choose crypto IPSec transform set, name of the transform set, and be using that ESP transform using ESP with triple dash, and using for authentication ESP MD5 and HMAC for origin IPSec tunnel itself. We do the same configuration here. So the command, actually you can easily copy paste from your origin mirror configuration. So IPSec, we have a crypto IPSec, and transform set is T set, and using ESP triple dash and ESP MD5 HMAC. Here we go, we have the same configuration which we have on site A, no difference from both sides. So we have our transform set. It's time to create our crypto map, and for crypto map the command is crypto map, and we can name it as a CMAP, which stands for crypto map, and we can use that any sequence number. Again, don't use the lowest one, you can use some number later. If you have another CMAP with lower number, we can shimp into the configuration. And we're using IPSec ISAKMP. So we need, of course, we receive a message from the router. So this new crypto map will remain disabled until a peer and a valid access list have been configured. Okay, let's configure the peer, set peer. Okay, before choose a peer question mark, as you can see here, we can set peer and transform set we created. So we choose the set peer, and our peer in this case is 13.0.0.3 site B router, and we create the transform set, transform set T set, which we create earlier, and this is the interesting traffic part, which we create the access list for that. So match what address is, we call it VPN traffic Here we go. And this is our crypto map created successfully. As you can see here, let's take a look together. Crypto map name, sequence number, and the method IPSec ISAKMP. We set the peer, router B side, and set transform set. The transform set we create earlier, and we have a match for interesting traffic. The ACL we create as VPN traffic. Let's do the same configuration on the other side. And here we go. We're going to create our crypto map, CMAP, 10 IPSec ISAKMP. Something wrong. Crypto map. Oops, forget the map command. Crypto map. Name of that 10 IPSec. Here we go. Now it's time to set the peer and site B. Our peer will be 12.002, which is site A router. We have a set transform set as tset. We create that earlier, and we have a match address VPN traffic. Here we go. Let's take a look. And we have a crypto map name and methods. We have a set peer, site A router, transform set, tset we create earlier, and the VPN traffic for interesting traffic. So technically, we finished define IPSec Phase One ISAKMP policy. We defined the IPSec Phase Two, which is original IPSec policy. We create our crypto map. We didn't apply yet, and we're going to apply it now. So let's apply on both sides, and to verify, let's take a look at the configuration. So we did all these things. We create our tset, we apply and define, and now we have to apply our crypto map, which happen on interface level. So we going to our configuration, and as you can see here, we have public is G00.0. Oops. Okay. Yep. So let's go and apply there. Here we go. So exit, do show IP interface brief, and here we go. We have a G000 interface G000, and the command for that is a crypto map. And what crypto map we create a CMAP. So ISAKMP is on. So enable, and we go to interface G000, which is our public, and we use the crypto map CMAP when we apply it. So now we have a full configuration. Let's take a close look. Crypto map on interface, and we have a crypto map name. Here we go. And now it's time for testing. Before that, we have some verification. Show crypto ISAKMP SA, and we don't have anything here. Show crypto ISAKMP SA. This is for verifying the phase one is up and running. Another config command to verify is crypto. Show crypto IPSec SA. Here we go. So this is a good command, also showing us some information regarding of the IPSec configuration. What is our local IP address? What is our destination or remote IP address? And this is an important part. We need to take a look. How many packets encrypt? How many packets were received decrypted? How many digest? And this shows us what is our local crypto endpoint and what is our remote crypto endpoint. So at the moment, we don't have any phase one. So let's go back to our configuration and start initial some interesting traffic. So we go to the server and start ping 192.168.100.10, which is IP address of the laptop here, and press enter, and the traffic start initiate from 192.168.10.0 network, hit the gateway, which is this router, And when the router realized that this part of the ACL is considered as interesting traffic, so it's put on a tunnel. As you can see, the last pings came up, and the tunnel should be established by now. And it's normal you lose 1 or 2 pings, and then after that your IPsec is up and running. So we run 1 ping there, there's a couple here, and let's go back to the router and check. And as you can see, we have a ISAKMP SA is up and running nicely. Destination is site B IP address, source is site A IP address. It should be the QM idle. And another command is show crypto IPsec SA. This is the information that we can get it. So how many packets are encrypted, how many packets are decrypted here. So we can see that the number of ping is up and running. We have this information. And finally, we can see that what tunnel is using here. And let's do the same verification on site B and phase 1 up and running. Show crypto IPsec SA, and here we can see the other side. So we have 9 and 10, and IP are up and running. So technically, the packet from here received to the site A, hit by ACL, considered as interesting traffic, then go through the VPN tunnel and encrypt that and receive here. So when reply, we can have the same testing ping from here, from the desktop, go to the command ping 192.168.10.10, which is our server, and here we go. So this number technically, previously we have 10 encrypted and 9 decrypted, should be increased now. Technically we have 14 encrypted and 13 decrypted. And site B also was other way, so we're expecting to have a 13 and 14 for encryption and decryption. I hope this video is informative for you and learned new thing. If you enjoyed the video, please watch, learn, subscribe, and share among your colleagues and friends. And see you in the next tutorial.